2301, Section 100. This is Section 100. I'm the instructor, Mark Barsamian. You can call me Mark. You can call me Professor Barsamian. You can call me Dr. Barsamian. You can call me Mr. Barsamian. I'm comfortable with any of those, whatever you're most comfortable with. Again, I'm comfortable if you call me Mark, that's fine. So this is lecture 1. For how many of you is this your first day of college? All right, very cool. Well, welcome to college. I hope it's I hope it's good. There are, as I mentioned, there are handouts on the table up there. Please put your name on this because, as you can see, there are a lot of these handouts, and if I find them around the room, I want to know who to give them to. Also, notice there are 3-hole punched. So the things that I hand out on paper in this class are always 3-hole punched. I would recommend that you get a notebook and keep stuff in a notebook so that all of your 2301 materials are together in a notebook that you can refer to. Handouts that we do in class, there are a lot of those. There are quizzes and exams. They'll always be 3-hole punched. Quite often, I have students, come to my office hours, and I'll refer to some paper, and they'll say, "Oh, that's in my other notebook. It's in my dorm," or "I don't have it. I'm not sure where that went." You want to keep all of your quizzes and exams and all the handouts because all that stuff comes around again. Later exams use questions from earlier quizzes. The final exam uses questions from quizzes and exams throughout the semester. So you want to hang on to all this paperwork. All right. I do have notes I want to try to keep on task. So course organization. Your entree into the course is probably, the simplest thing to remember is just go to Canvas. So if you go to Canvas and you click on the Canvas site for our course, you don't find too much. What you find mostly is these links to what's called WebAssign, associated links for that, associated links for a whole bunch of WebAssign assignments from our textbook. Stewart is the name of our textbook. But you don't find information about how the course runs. And that's because that's all not in Canvas. It's on a public-facing web page. I mean, Canvas has public-facing web pages now, but they're basically almost no information on them. My public page lives outside of Canvas entirely. You can get to it by coming to Canvas. If you come here and you click on this public web page for Math 2301, you get to this page, which lives again outside of Canvas. You can bookmark this page. You can get here without going to Canvas first. So if you're savvy with bookmarks, bookmark this page because everything that we do in this course, all the information about the course, is on this page. Again, you go to Canvas to get access to that homework stuff, the WebAssign system. You'll go to Canvas to get scores on quizzes and exams. Well, they are not generally posted during the semester, but you'll get at the end of the semester your grades. All right, so let's look at this page. First of all, there's information about me, my office location, office hours, email, phone number. The recitation instructor, you'll have recitation tomorrow. Alexander Palo is your recitation instructor. There's information about, well, first of all, the final exam date. All the sections of 2301 have a common final on Thursday, December 10th. I'll grab a handout from the table over there. Hi, grab a handout, and what's your name?
I'm Parker.
Parker Chambers must be. All right. So your travel plans need to accommodate, for instance, our common final exam. It does not work to say, well, I've already bought my ticket, I'm leaving on Wednesday. If you already bought your ticket and you're leaving on Wednesday, then you just don't take the final and you don't get the final exam score. All right, attendance for this course is required. It's not part of your course grade, but I keep track of it. I want to know who you are. I also want to know who's here. So if you miss class, you won't learn the wisdom that I impart in class. There's stuff on here about what happens if you miss a quiz or exam because of illness or because of university activity. I'm not going to go through all this because it's all on the webpage, but you'll need to come here. There's important stuff here about the attendance policy, and that policy is what I will follow whether or not you've read it. Okay, so it's important that you read it, because if you do something that causes you distress and it's because you didn't actually read this policy, that's on you. But you probably all just woke up and you would probably go back to sleep if I tried to read through the attendance policy. Stuff about cheating, some stuff about electronic communication, just basic stuff. So go to the web and read the web page. We'll have a diagnostic test later today. That test does not count towards your course grade. You won't get the test back. It's a diagnostic test, and it's just for my information. But it's to flag students who are having particular difficulty with prerequisite algebra. So all across the country, calculus courses like this are notoriously hard for students to get through. We instructors observe that usually when a student struggles in calculus, it's because they actually don't have basic algebra skills. So, rather than tell you if you're having bad trouble with algebra, drop this class and take algebra, that's not a very appealing solution. What I've done here at OU is I've created a course to run alongside this course, and that course is called D301, Math D301. And that's a course that is called Learning Laboratory for Calculus. It's a 1-credit course. It meets either once a week on Tuesday or once a week on Thursday, and it goes over just the algebra that you need for this course this week. So each week I've created plans for that, for D301, where you'll go over algebra stuff that you're going to need to succeed on your calculus homework that week. So it's kind of a just-in-time review. So really, you could all, I'm sure, afford to take this course. I highly recommend it. All right, textbook, WebAssign. So our textbook is this, Stewart Calculus. It's a fantastic book. I'll be referring to it a lot throughout the semester. And WebAssign is, you'll probably access this book, most of you will access this book through the online system called WebAssign. On that list of, on the handout, there's a list of homework exercises. Those are all from the textbook. Most of them are actually in WebAssign. There are a couple of homework exercises that are not in WebAssign. They're just in the textbook, which you'll access online. Those are underlined. 405 exercises. That's the course right there, this content. And so this whole course, the lectures, the quizzes, the exams, the recitations are all designed to provide structure for you to learn the content that's embodied in these exercises. So I would suggest that you check off these exercises as you do them. Also, WebAssign is great for the publishers because it's a cash cow. They make a lot of money on WebAssign because you have to pay for a subscription. It's great for the university because you get cheap textbook, but it's not a great system for learning calculus. It's only a system for checking whether you got the right answer on a problem. The real skill in math is being able to communicate math, be able to write math down. All of your quizzes, all of your exams are written. So I would strongly suggest that you keep a notebook where you write down solutions to problems before you type them into WebAssign. And then type it into WebAssign and see if you got the right answer. But you're going to need to have that skill of writing down math. And if you come to my office hours, I'm going to want to see your notebook so we can look at the way that you do math on paper. And so think of this as a way to organize that project of doing all these exercises on paper, checking the answers in WebAssign. Grading is here. You accumulate points up to 1,031 possible points by recitations, quizzes, exams, final exams, and WebAssign. And then I convert your score to a percentage, convert that percentage to a letter grade. That's all explained there. Calendar is on this handout, which all the handouts in this course are also available on this website. So if your dog or cat eats this, you can print out a new one, or you can come to this calendar on the web page, and you can see a printable PDF of this calendar, for instance, there. And then here's the whole semester, and this is this calendar, but with hyperlinks. So handouts that I hand out in class, there's a hyperlink here. Video, haha. We video these lectures, so if you miss a day of class, you watch the video, you don't miss anything. And then things like recitation details are here. For instance, tomorrow's recitation details are there. Next week's recitation details are there. Quiz information is there. So there are reasons to have this paper copy, and then there are reasons to come and refer to the online calendar as well. And then finally, about the grading, back to the grading. Since you accumulate points and those points are converted to a percentage, you can keep track of your own grade throughout the semester by writing your scores on this. In this handout, there's a grade calculation worksheet. You can write down when you get a graded item back, a quiz or an exam or a recitation. The recitation, you get points for going to recitation. You need to participate. You can keep a running total of your scores, keep a running percentage, and keep track throughout the semester of your letter grade. So there should be no surprise. You don't need me to tell you on Canvas what your scores are because you've written them all down here. Okay, that's the course information, I think. These are really weird old rooms in this lecture hall. So that was meeting part one. I didn't put that on the chalkboard. Meeting part one was organizational. Meeting part two. Questions about canceling. So, one, is that equation true? Let's get some hands. How many people think it's true? Great, let's check. Seems like I'm wasting your time, right? Right? 0 over 0 is 1? No. 0 over 0 is not 1. 0 over 0 is undefined. All right, another related question. Are f of x equals x plus 1, x minus 3 over x minus 3, and g of x equals x plus 1, are they the same function? Okay. I see one person nodding their head, one person shaking their head. What's your name? Jacob. Why are you shaking your head? Wait, say it again?
Like when you're dividing by the x minus 3, you have to divide the entire numerator.
Well, let's just do a check. I'm a little bit not quite clear on what you meant, but so let's do x, let's do f of x, and let's do g of x. So when x is 0, f of 0 equals 0 plus 1 over 0 minus 3 over 0 minus 3. Now I can clearly cancel. I don't even need to do this arithmetic. I know that's going to turn out to be negative 3, but I can cancel that. So I get 0 plus 1, so I get 1. G of 0 is 0 plus 1, so that's 1. Good, they match. Let's do x equals 1. F of 1 is 1 plus 1, 1 minus 3 over 1 minus 3. Okay, I could do that math, but I don't really have to. That's something I can cancel, so I get the number 2. G of 1 equals 2. Great. Let's skip ahead. Let's do f of 3. That's going to be 3 plus 1, 3 minus 3 over 3 minus 3. I can't cancel because that's 4 times 0 over 0. That's 0 over 0. That does not exist. G of 3 does exist. So these are not the same function. So this, if we're given this expression and we're guaranteed by somebody that x is not going to be the number 0, then yeah, we can cancel. But if we don't know what x is, we have to leave this as x over x. And if we're given these functions, given this function f of x, and somebody guarantees us, here's a function, and I can guarantee you that x is not equal to 3. Well, then you can cancel it, and you can cancel the x minus 3 and use this function instead. But if you don't know what the value of x is going to be, you're stuck with this function. Question?
It's not like a limit, like how from one side.
Oh man, you're stealing my thunder. Oh, dang it. Right, so we're going to talk about that. Wonderful. Great. So the most important concept for me, for calculus, for the first month of the course, is when can you cancel terms and why? When can you cancel terms? And why? So it's going to turn out that that concept is crucial to something that calculations that we're going to do when we do what are called limits and derivatives. Hi. What's your name?
Amelia.
Okay, great. Thanks. Yeah, that's all right. You can watch the video. Okay. So we're going to introduce what's called the limit. So here's the symbol. So it's written that way. It's spoken, the limit as x approaches a of f of x is L. The usage of this symbol, A and L are real numbers. So f of x is a function, of course. A and L are real numbers. Now that is going to change in the next couple of days. We're going to have a different version of limit where we change our restrictions on what A and L are. And here's the meaning. As x gets closer and closer to A, but not equal to A, the values of f of x get closer and closer to L. So that's the definition of limit. All right. Well, let's return to this example. So we're going to return to these functions. Let's make a graph of these functions. Now, it might seem like you can't possibly make a graph of that function. This graph is easy. G of x equals x plus 1. It goes through 0, 1, 1, 2, 2, 3, 3, 4. And it's a straight line. Now, the graph of f of x actually looks very similar. Who is it that said to think about the whole? Yeah, so remember when we were computing values of f of x, most of the time these terms canceled. So the graph of f of x looks very similar. It goes through 0, 1. It goes through 1, 2. We computed that. We skipped this point. It goes through 2, 3. And so at all other points, it looks just like that graph, except there's a missing point here. There's a hole at 3, 4. Now let's think about the limit. Let's think about the limit as x approaches 3 of f of x. Well, we can see from this graph that when x is close to 3 but not equal to 3, the y values, so here's an example of that happening, the y values are close to 4. Okay, so again, when x gets close to 3 but not equal to 3, the y values are close to 4. So we abbreviate that sentence that I just spoke by writing this. Another way of saying it is the graph is approaching the location x, y equals 3, 4. I don't say it's approaching the point because there's no point on the graph at that location. I say it's approaching that location. Let's look at the limit of g of x. LIM as x approaches 3 of g of x equals 4 as well. Because on this graph, if I make x close to 3 but not equal to 3, and I look at the y value comes out, so x close to 3 means that y is going to come out close to 4. So let's reiterate. Remember, f of 3 does not exist. G of 3 equals 4. These are not the same functions, but they have the same limit. So the idea of the limit is a trend in behaviors. All right, I want to make sure that you have, we got plenty of time. So throughout this course, throughout calculus, you'll see that calculus has to do with articulating and making precise the idea of some kind of trend. So, f of 3 does not exist, g of 3 equals 4. That's not a trend, that's just arithmetic. But this idea of limit is articulating a trend in those graphs. The graph of g of x is also heading for the location 3, 4. It happens when you get there, there's a point, whereas on the graph of f, there's a hole. But in terms of the limit, it doesn't matter. The trend is both graphs are going for that location. All right. Example, so that was all example 1. Sorry, you get out of practice when you spend the summer on the beach, which I didn't do. You get out of practice when you spend the summer mowing the grass. All right, example 2. Sketch a graph of a function f of x that satisfies all 3 conditions. So lim x arrow 3 with a plus sign, f of x equals 4. LIM x arrow 3 with a minus sign, f of x equals 2. F of, I wish I had changed these numbers. F of 3 equals 5. So we've got 3 conditions here. Now there's also a new symbol here, this superscript plus and this superscript minus. I'm going to get to that in a minute. The key thing, though, is to realize that these symbols like this, the limit symbols, and this symbol are about locations on a graph. So this symbol tells us that on the graph of G, there's a point at the location 3, 4. This symbol tells us on the graph of F, the graph is heading for a location with x equals 3, y equals 4. So in these symbols, that's an x, that's a y. That's an x, that's a y. That's an x, that's a y. So there are 3 important locations. So we're going to plot the important locations and label as holes. Label x, y coordinates. So here we go. I've got three important locations. Looks like 3, 4. Uh, 3, 2. And 3, 5. You might say, oh, those aren't measured right. Well, they don't need to be because I've labeled them. So you can save a lot of time by not bothering to make tick marks on the axes. Just what's more important is you label the x, y coordinates. And then decorate the graph to satisfy the conditions. So we're going to add features to satisfy the conditions. So let's see. This condition, f of 3 equals 5. Well, that means that there's got to be a hole in the, there's got to be a point on the graph at 3, 5. Now, what about these symbols? LIM x arrow 3 superscript plus. This is spoken the limit as x approaches 3 from the right of f of x is 4. So in other words, on the graph is heading for this location, 3, 4, from the right. So I'm going to put something like this. Here's an example of a graph that looks like it's heading for that location from the right. And this is telling us that as x, this is spoken the limit as x approaches 3 from the left of f of x equals 2. So that means the graph is approaching the location 3, 2 from the left. So there I've made a graph with all three important locations labeled. All right, now, you'll hear me nag throughout the semester the importance of reading. You can read in the most weeks, you can read somewhere in the national news about how, well, if you read, you'll read about how we're not reading as a society. People are no longer reading. And in particular, throughout your math career until now, you might not really have had to read a math book. There's usually a focus in these courses on doing whatever we can do to just get you through this course. My biggest focus here is to turn you into a reader of math. When my college career was mainly about my relationship with my textbooks, sitting down and reading through them, and puzzling through and figuring stuff out. Once I realized January of my freshman year that I could do that, it was really liberating. Calculus, chemistry, physics, economics, everything became straightforward because I could just read the book and figure stuff out. So my goal is to turn you into or to help you on this project. Reading a math book is a skill. It's hard. I won't pretend. If you haven't had to do it until now, you're going to think it's impossible. But I'm going to encourage it by doing a couple of things. So, for instance, 1.3 number 2, 1.3 number 15, 1.3 number 13. Those are all exercises on your homework list. There are excellent book examples in section 1.3. Example 1, example 3, example 4. So it doesn't make sense for me to try to make class time to discuss similar examples. What makes sense is for you to read the book. This example is not in the book. There's no example like this. So I will prioritize in my lectures things that are not presented in the book. So you want to make sure that you read the book, read its examples, and do your homework. Every quiz and every exam will include at least one problem that's a book example. That's the carrot. All right, if you would put everything away, we're going to do this diagnostic test. Put phones away. So this diagnostic test, as I mentioned earlier in the hour, does not count towards your, you can actually leave that on for a minute. This does not count towards your course grade, but it's 10 points. If you score 7 or less, it's really highly recommended that you take that Math D301. And again, really all of you could stand to have an algebra review while you're taking this course. Okay, so again, everything put away, no calculators. You can turn off the